Hey everybody, welcome back. So today we're going to talk about the vessel setup tool. So the first thing I'm going to do is I'm just going to drag in a new multibeam file here, just like I have in other videos. So we get this new conversion action. We'll convert our line just by hitting start here. The cluster starts, it takes a few seconds, and then the conversion finishes. I hit start, it has the second step to do all the processing. It takes a little bit, and then it finishes, and then I have process data. Right, so 2 steps. So one of the things that when you convert multibeam data, what you get is the position of the sonar and the other sensors. So if I go up here and I go to vessel offsets, what I get is a tool that gives us a view of those sensors in relation to each other, so you can identify where things are, if your offsets make sense, and you can alter those offsets, and I'll show you that a little bit. So the first thing you see is something that's kind of weird. There's this boat floating in space. So what I include, and I could turn off and on here, is this 3D model that gives you sort of like a sense of scale, relation to where the boat would be, where your where your sonars are attached to a boat. And I give you a few different options. These are loosely based on vessels that we have. So if you go into the cluster download that you have, there's this vessel STL files folder under this path, and you can see these OBJ models, right? So you can actually go in here and drop in a different one if you want to include something that looks more like your boat. You can make that and include it, and then if it's in that folder, it shows up here. Anyway, so I know that this one is a smaller boat, so I'll click on the smaller boat. And for now, I'm going to go over here and I'm going to click on waterline, and I'm just going to turn the waterline off just so you can see things. So the idea is that here you have all of the equipment, right? You have a sonar transmitter, a sonar receiver, an IMU, an antenna, and these things are all positioned, relative to a reference point. In this case, ours is the transmitter. I know because if I click on it, everything is 0. So that's where everything else is referenced to. You can mouse wheel around, and to get an idea of where these other sensors are, you see the receiver, right? Forward, starboard, so the receiver is to port of the transmitter, right? It lights up. But again, there's just sort of this weird boat in the way. So let's talk about that real quick. If I go to basic config, I get the position of the boat from this 0 point. This doesn't affect the data or anything. Again, you can just turn it off if you don't like it. But what you can do is you can alter in this basic config where the boat is from your reference point. So positive down, I just want to move the boat up a little bit. Oops. Update, that's actually pretty close. So maybe like 1.1, something like that. Again, if this was your data, you could do something more impressive than this, but for us, I just want to put it so it sort of makes sense for where the boat is. You can also adjust the size of these little cubes down here. Okay, something like that. So what's nice, again, is that once you have the boat, you can go over here to waterline and turn that back on, and that sort of makes sense, right? So I'll mouse wheel off so it's not as bright. This is where the waterline is on our boat, which kind of lines up with where it might be on a boat that's in the water. So this is nice because, if you're wondering like, oh, did I get the sign wrong? It's pretty clear because, it makes sense in this little picture. There's something else we can do because we have these other things like an IMU and an antenna that aren't in our data here. If I go to antenna, it's all 0. And that's because the antenna offset isn't in the multibeam. It's actually in the positioning file from the Planix POSMV system. But I can import that. I have it right here because I just did this. So it's in the last scene files. So I can just click on one of these guys, one of these 000 files, and I import it, and it's going to take the offsets from where that equipment is in the POSMV system. Right, so I don't have to go over there and say, oh, what did I enter, and then go over here and then enter in here and then do all of this stuff. You can just import these files because the files know where these sensors are positioned. So now if I look at it, right, the antenna is on the port side and sort of above the cabin, which kind of makes sense. This boat actually lines up pretty well. I think it's pretty close to the boat used in this example. And the IMU is somewhere in the center-ish. That looks pretty good. Okay, so the rest of this is basically, you can go in here, you can edit these things. If you want to add another entry, all of these entries in this vessel offset data are time-stamped, and new multi-beam data is going to use the nearest previous timestamp. That's similar to how Keras works, and probably most other processing systems I'm not that aware of. And here's your serial number and the sensors. And that's basically it. So one thing I want to show you is that now that we have entered this new information, and I'm just going to close it, it's going to ask me if I want to save. So I'm going to hit yes. And you have two options. And this dialog is a little weird, but you can either do yes to create a new vessel file, and the vessel file contains this data for multiple boats and multiple times, sort of like the Keras HVF, but it auto creates, and it sort of is a nice way of keeping a record of these changes, a centralized separate file thing. Or you can hit no, which is what we're going to do, and just update the converted data that we have here. So I'm going to hit no, it's going to update the multi-beam data. And you'll see we have a new action. So that's kind of weird. Why would that be? So when we went into the vessel setup, we added a new antenna value. Your antenna value was 0, and then we gave it a position. And the position of the antenna value is actually one of the parameters used in computing uncertainty. So this thing knew, I'll go ahead and kick it off so I can show you again. This thing knew that changing an uncertainty value means we have to compute the uncertainty again. So if I go in here and, for instance, back to the vessel offsets, first of all, you'll see that it kept all of our changes, which is good. It's good that that happened. If I went down and changed, say, the waterline, let's say I entered this in sys incorrectly. I actually want it to be 0.7, negative 0.7. I update, I close, I save the changes, I update the multi-beam data. Now we have to process starting with sound velocity, because that's where that change is included in the processing system. So I hit start. It's going to go through those 3 steps: sound velocity, georeferencing, and uncertainty, and now we're processed. So any changes you make here are going to update this system and generate a new action to get us to where we want to be, to that fully processed system. The fully processed answer for our new offsets, angles, waterline, whatever. Okay, so, and this goes for angles, and I can go through and do the whole thing. Here's your uncertainty values, right? I can change one of these, and it's going to do the whole thing with update, close, save, update multi-beam data, right? New uncertainty action. And we can keep doing this. The last thing I'm going to say is, if you click on this guy, right, this is the day that we've been altering here, and you look at this XYZ RPH thing. So this is the actual record for these data values, and you go down here and you can see the same thing, right? If I go to waterline, I see negative 0.7. So this is like the raw form of our vessel setup data. And that goes for all of these things. All of these things generally have a graphical system that lets you control these things. All right, and I think I'll stop it right here. Thanks for watching, and I'll see you in the next video.